We've been factoring with all positive numbers, but now in this lesson, 23, we are going to look at factoring with negative numbers. So our first problem is going to be x squared minus x minus 6. So we're going to look at what that would look like with our algebra tiles. So an x squared is going to be a blue one. A minus x, this is our x size one, but a minus is going to be a negative, so we're going to have that as a red one. And then minus 6. So we need 6 little ones, and they're going to be on the red side because that means that we are looking at negative numbers. Now with negatives, especially when we have a negative over here, we're going to be looking at how can we arrange these, and it's probably not going to work. I can't put the negatives here. I need to put them across, or I need to put, an X here, but how can I make this work? Because this isn't going to fit. I mean, I can't draw them down here. If I put them over here, we got too many. Well, we had talked about negative pairs. So a positive and a negative are going to be 0. So I can add as many positive and negative ones as I need to be adding 0, but to make the rectangle fit. So here's one set of 0. Here is another set of 0. And let's see if we can make it work out with these. So maybe I want to put, 3 negative ones down this way. And then I can put these ones up here and then across. And this is going to make a rectangle. And remember, when I add 2 x's to negative 3 x's, I'll get that negative x that we were looking for. And then I have negative 6 ones, and then I have the positive x squared. So what is this factor? Well, across here is an x and then 2 positive ones. So a positive x and 2 positive ones. So this factor across the top looks like x plus 2. And this factor down the side is a length of x. And then these are negative because they multiply here with a positive and they become negative. So it must be negative 3's here. So this is an x minus 3. So again, if I multiply a positive and a positive, I'll get a positive. A positive and positive here makes positives. This positive with negatives down here, positive and negative, results in a negative. A positive and a negative over here results in negative. And so that's why these at the bottom are negative, because this part of the factor was negative. Let's try one more, and then I'll show you how I do it on paper without the algebra tiles. I have an x squared, I have minus 2x, and I have minus 8. So I'm usually going to line my x squared up in this corner. I'm going to put these 2 out, and I know that I'm going to have to be adding some 0 pairs because this is just not going to work. But let's see how many 0 pairs I might need to add. Okay, if I add one set of 0 pairs, I'm going to want to put all the positives together and all the negatives together. Well, I could move these over here. I still have 2 extra ones. So if I add another 0 pair, and I put the positive ones up here and the negative ones here, I can move these right over here. And now I have a rectangle. This still adds up to being this right here. I have 1x squared. I have a positive 4x, but I'm subtracting 2x. So if I just cover those up for a second, I have a positive 2x. Oh, I have a positive 2x. Did I start with positive? That's probably what I did. Okay. Here's my x squared. Here's my negative 2x. And here are my negative 8. So if I line these up, I know that I'm going to need to add some 0 pairs in here to make this a rectangle. So why don't I add a positive and a negative? I'm going to want to line up my negatives with negatives and a positives with positives. So I'll put this one down here. That means I could move these two over here, but I still have some extra ones. So I'm going to add another 0 pair. I'm going to put the negative up here and the positive down here, and let's see if I can rearrange these. I can. Okay, so what are my factors? Across the top, this is positive, so it needs to have 2 positives to make it positive. And then here, these are negative multiplied by a positive. So I know I'm going to have negative ones here. So this is x minus 4. And this one is x, and these are positive. So we're going to make that a plus 2. All right, and that's what those look like. Now let me show you how I can do it on paper. If you like the algebra tiles and draw them out, make sure you use some kind of different symbol for a positive and a negative. So I'll go ahead and start with this one. Here I know what the answer is, but let's pretend that I don't know this answer yet. When I'm looking at this, I want factors of -8 that when I multiply them by this positive x, they will add up to -2. So before, when we were working with positive numbers, we didn't really account for any negatives. If we have this negative number here, that means that a +8 and a -1 would multiply together to be -8, or a -1 and a +8. We could also have a +2 and a -4, or a -4 and a +2. Because there's no coefficient here, there's nothing I need to try to multiply with the x, so I can just go ahead and add these up and say which one is going to add up to -2. Well, this adds up to 7. Oh, this is the same way, I just wrote it different here. We'll do it that way. This is going to add up to -7. This will add up to -2, and this one will add up to a +2. So again, I'm looking for a -2, so I know that it's this set. And so I can write them in. Because there's no coefficient here, I can just use my x, I'll add 2, and my x minus 4. Now hopefully you're not confused. Right here, I just listed them in a different order. Both of these are correct answers. So let's look at that first one that we did with algebra tiles now. We had x squared minus x minus 6. So again, I'm looking for factors of 6. There's 6 and 1, and either the 6 is negative or the 1 is negative. There's 2 and 3, and either the 2 is negative or the 3 is negative. So when I add these up, I would get a -5 or a +5. I would get a +1 or a -1. And I'm looking for a -1, so I'm looking at this one right here. So this is a +2 and a -3. There's no coefficient here, so I don't have to worry about the difference there. And I can write it like this. Now, if you need to write out all the factors every time for a while until you get used to seeing what they are, this is a great way to start working these problems. I will say that as I get more comfortable with it, I might be writing my factors of 6 and just say I have 2 and 3 and I have 5 and 1. And then when I'm looking at this one, I say, I need the difference to be a 1. So I'm not thinking about negatives and positives yet. I'm just saying the difference between the factors. Well, the difference here, oh, this is 6. 6 and 1. The difference here is 5. The difference here is 1. I'm looking for a difference of actually -1, but that means these two are going to be the numbers I use. So I would put in my 2 and I would put in my 3, and then I have to think. I want them to add up to be a -1. So one of these has to be negative. If the answer comes out negative, then I want the bigger number to be negative. And then I'll put my positive sign here. So I'm just showing you what you might be getting to. If you're getting really comfortable with this part, then maybe you're just writing the factors and thinking about the difference between them, and then figuring out how to put your positive and negative signs. Oh, I skipped an example on our notes. Let's do this one on paper. So still no coefficient, that's nice. So I'm gonna look at this 7, factors of 7. 7 and 1 or 7 and 1, right? But I could have both of these be positive or I could have both of them be negative. Because I need this negative when I add them up, this must be my answer. So when this is a positive, it doesn't make it much harder than when all of them are positive. If there's a negative here, it just means that both factors will need to be negative. So now when I multiply a -1 and a -7, I get a +7. If I add a -1 and a -7, I'm going to get that -8. All right, let's do example 4. All right, 12 has lots of factor choices, and a -12 means I can go either way. So I have 12 and 1. I have 6 and 2. And I have 3 and 4. So I still only have a 1 coefficient here. That does make it easier. I'm now just looking at which one of these adds up to be a +1. My difference between 12 and 1 is 11, so neither of these are going to work. The difference here is 4, so I either have a +4 or I have a -4. Oh, this one's negative, and this one's positive. And then down here, I have a +1 or I have a -1. So looking for that positive x or +1, it's going to be this one right here. And then because I have no coefficient, it makes it pretty easy to put it in. Remember that we can always check by foiling or distributing through. So my first one is an x². My outside is a 4x. My inside is a -3x. And my last ones are going to be that -12. When I add these together, I'm going to get a +x. And then I do indeed have what I started with. Okay, for this last example, it's a little bit more difficult because we do have this coefficient here. So just like before, we know that 2x² is just going to be a 2x and a 1x. But we're going to be able to use this forwards or backwards, with whatever the factors of -12 are. So this one, it's going to have a lot. We can do 12 and 1, and we can do it with a negative here or the negative here. We could do 6 and 2, again with the negative here or here, and then we can do 4 and 3 with a negative here or here. So we have each one of these will have 2 ways. It can either be with the 2x or the x. So if we do it with the 2x and the -12, we would have -24, and then the 1 and the x would be x. If we did it the other way, we'd have a +2x and a -12x. So then you're adding these together, and I can see that neither of these are going to be close to 5, so I know that this way didn't work. If I do the same one here, these numbers are just going to change signs, all of them. So the first one would be a +24x and a -x. And then the second one, we would switch. So we'd have a 12x and a -2x. So once I do this one, if none of my numbers none of them are this number, then I know that the one where I switch signs isn't going to work either. So we're just going to do one of them. And then if we get close by having this right number but the opposite sign, then I know to go to the other sign. So -6 and 2x is a -12x, and then here would be a 2x. If I switched it, then I'd do 2x times 2, which is 4x, and then -6 times x. Okay, so my difference here, I got a negative 10x, and on this one, I got a negative 2x. So again, I have not gotten to my 5x yet. So it doesn't matter if I switch the signs. These would just switch to a positive 10x and a positive 2x. So these are not going to work. Now I'm down to this last one. Negative 4 times 2x is a negative 8x, and then 3x. Or if I switched it, it would be a 6x and then a negative 4x. So which one of these? This is our negative 5x, and this one is going to be a positive 2x. So you can see I've gotten to the 5x, but we need it to be positive. So it's not this one, it's actually going to be this one right here. I'm going to go back and I'm going to put in my factors. And then which way did it work out? It worked out when I had an 8x and a 3x. And that 8 meant that the 2x and the 4 were multiplied. So if I want the 2x multiplied by the 4, the 2x is on the outside. So I want the 4 right here, and I want the 2 on the inside. I'm sorry, not 2, 3. 3 on the inside. These numbers right here. And this is a negative 3, and this is a positive 4. Now, at this point, there was a lot of writing here. What if I somehow got confused? I'm going to want to double check this. So I'm going to do my FOIL. First is 2x squared. Outside is 8x. Inside is negative 3x. And last is negative 12. Then I'm going to add these together in the middle. I get my positive 5x. And so I'm correct. I did it correctly. So I'm here to say that I'm sorry, your homework doesn't take you just 2 minutes. You should have some writing on it. You should have, maybe you don't have all of these. Maybe you just have half of them because you guessed that it wasn't these two. So maybe you started down here. But you should have work on your paper. And it's not going to take you just 2 seconds to think about this. It's going to take you a minute or two to figure it out. Maybe it takes you 5 minutes to do each problem. And if you are not sure, if you're not, like, did I mix them up or anything? You can always check and get back to it. Okay, if we ever came across a negative 2x squared minus 5x plus 12, and we think, well, now our negative's over here. Yes, and you could have a negative 2x and an x and then switch it with a positive 2x and a negative x and use positive numbers here. You could do that when you're figuring out. Or if you have a system for, this one's negative, but I always like my x squared positive, you can factor out a negative 1. So if you factor it out, you do need to keep it right here. When you factor it out, it's like saying, okay, I'm going to take this number, this negative 2x squared, and I'm going to divide by negative 1. That's going to give me a positive 2x squared. If I divide a negative 5x by a negative 1, that gives me a positive 5x. If I divide a positive 12 by a negative 1, that's where I get my negative 12. So really, all of these have switched signs, and you have factored out that negative, and now you have a problem that looks just like before, and we have a positive number here, which is usually a little easier to work with. Okay, now we're looking at lesson 24. This is polynomial division. So what I want to start with is, how do we normally divide something? If we had 748 and we were dividing by 6, and now I'm going to write up here, we divide, we multiply, we subtract, and we bring down. So we first look at how many times does 6 go into 7. That's our division. It goes in 1 time. Now we're going to go 1 times 6 is 6. That's our multiplication. Then we subtract right here to see how many is left over, and then we bring this 4 down. Then we start over. How many times does 6 go into 14? That's our division. It goes in 2. 2 times 6 is 12. That's our multiplication. Then we subtract. 14 minus 12 is 2. Then we bring down. We bring down this 8. We start again. Our division. How many times does 6 go into 28? And it goes in 4 times. 4 times 6 is 24. That was our multiplication. Then I subtract. I know I have 4 left. That's my subtract. I don't have anything left to bring down, so this is my remainder. When it's my remainder, sometimes, hopefully, at one point you learned that you can just make it a fraction. So it's 4/6 left. Because I was dividing 4 by 6, I can't make it a whole number, so I can leave it as a fraction. Okay, so remember these steps: division, multiplication, subtraction, and bringing down. That is what we are going to do when we use polynomial division. So our first example, on your notes, it's example 10. We have 2x squared minus 7x minus 15, and that's divided by x minus 5. Now, when we're doing our division, we just want to think about the x. We'll get the rest of it when we do our multiplication and subtraction. But for division, if we just look at the first ones, that will help us. So if I'm just looking at this, how many times does x go into 2x squared? I can think of it as this right here, 2x squared over x. If I'm trying to reduce this as a fraction, I know that there's an x on both the top and the bottom. I'm going to get rid of one of them on the top and one on the bottom, and so it's 2x times. So that is the same division. I've just divided 2x squared by x, and I've gotten 2x. So that's what I'm going to put up here. Now, if you notice, I put it above the x value one just to line it up. It's not a huge deal if you put it over here, but I just like to line mine up. So I divided 2x squared by x, and I got 2x. Now I'm multiplying. 2x times x minus 5. So this is where you do use the whole thing. 2x times x is 2x squared, and 2x times negative 5 is negative 10x. Now I subtract. Do not forget that you are subtracting all of this. So it's like putting a subtraction sign around all of it. I like to distribute mine right away. So when I subtract, I just change the sign of everything on this row. So I'm subtracting. This one I'm subtracting a negative, which means I'm adding. I just go through and I change my sign so that now I can do it straight down and I don't have to remember that I'm subtracting and pulling that negative in. So negative 7x plus 10x, that gives me a 3x, and then a 2x squared minus 2x squared is 0. You should be getting 0 every time on your far left side, or else you are either at the remainder point or you didn't put the right number at the top. Okay, so I subtracted, now I'm bringing down. So I'm bringing down my negative 15. Again, now I'm back to my division. I'm asking, how many times does x go into 3x? Or if I had I had 3x divided by x, what would it be? Hopefully you can see that cancels and it's just 3. So I'm going to put a plus 3 up here. Now I'm multiplying. So 3 times x is 3x. 3 times negative 5 is negative 15. When I subtract, I'm just switching all my signs across so that I can really add. This is 0 and this is 0. There's nothing left to bring down. My remainder is 0, so I'm finished, and this is my answer. Number 11 on your notes looks like this. 12x squared minus 10x minus 28 divided by 2x minus 4. Remember, it's division, multiplication, subtraction, and then bring down. So how many times does this 2x go into the 12x squared? Or what do I need to multiply this 2x by to get 12x squared? Well, it needs a 6 and it needs an x. So now I multiply by the whole divisor. So 6x times 2x is 12x squared. And then 6x times a negative 4 is a negative 24x. So I divided, I multiplied, now I'm subtracting. So I just switch all my signs. I get 14x, and I get 0 right here. Now I bring down that negative 28, and I'm back to the beginning. I'm dividing. How many times does 2x go into 14x? Well, the x's are the same, so I just need to multiply this one by 7 to get 14x. So 7 times 2x is 14x. 7 times negative 4 is negative 28. So then I've multiplied. In my subtraction, I just change all the signs all the way across. When I subtract, I get 0. So this one I'm finished. The answer is 6x plus 7. I can always check my work, right? We just did a division problem. If you want to check your division problem, you multiply. So you could multiply 2x minus 4 times 6x plus 7, and you should get this 12x squared. So let's try. This one is 12x squared. Outside is 14x. Inside is negative 24x. And then the last is negative 28. We add these two together, and we get a negative 10x in the middle. And this is indeed what we used to start. Okay, we have 2 more examples. I realize that I skipped number 9. We'll go back to that after this last one. So example 12, we have 6x squared minus 19x plus 17 divided by 2x minus 3. I just want to note, if your problem ever did them in the reverse order, if it looked like this, you will need to write this in descending order. You need to always start with your biggest x squared at the front. Otherwise, you wouldn't be able to put 2x into 17 and you might be lost. They need to be in descending order, so you start with your biggest power first. All right, here are division, multiplication, subtraction, and bring down. So how many times does 2x go into 6x squared? Or what do I need to multiply by 2x to get 6x squared? Well, a 3 times 2 will get us the 6, and then an x, because the x times x will get us x squared. So now I do multiply by the entire thing. 3x times 2x is 6x squared. 3x times negative 3 is negative 9x. Now I'm subtracting, so I change all my signs. When I subtract here, I get a negative 10x. Here is a 0, and then I bring down a 17. Now, how many times does 2x go into negative 10x? Oh, now we have a negative. Is that going to work? Well, let's just multiply by a negative 5. So negative 5 times 2x is a negative 10x. Negative 5 times negative 3 is a positive 15. So I divide it, and then I multiply. Now I'm going to subtract. That means I'm going to switch this sign, and I'm going to switch this sign. So 17 minus 15 gives me 2, and negative 10x plus 10x gives me a 0. Do I have anything to bring down? I have nothing to bring down, so I'm finished. What do I do with this 2? Remember how I said before, you make it a fraction. But what fraction do I use? This is really ugly. This is your denominator. That's what you were dividing by. So you have 2 left, but you need to divide it by 2x minus 3. So you leave it in this form. Now this will be a little bit harder for you to multiply and check, but I promise you can do it. So you would write your answer like this, 3x minus 5 plus this fraction of 2 over 2x minus 3. Okay, now I'm going to go back to example 8. It was talking about square roots. So you have the square root of x squared plus 16x plus 64. What does that look like? Well, we know anything in a square root means if I want to take it out, it's got to be something multiplied by itself. So if this will come out of the square root, then this parentheses set should look just like this parentheses set, because that would be the same thing squared. It's multiplied by itself. If that's the case, if these look the same, then this number and this number should be the same as this one and this one. In other words, this x squared, if we take the square root of it, it's x. Or if we did, our first, we would have x times x is x squared. So I go over to my last, because these would be these two. I want the same number multiplied. Well, this is a perfect square, so I can use 8. So 8 times 8 will give me 64, and that's a plus. And then I can do outside and inside. My outside is an 8x, and my inside is an 8x. That means it's 8x times there's 2 of them, and that gives me my middle term. So the square root of this is actually just 1, right? That's a little bit tricky to think about, but if we had the square root of 9, we know that that's really 3 times 3, and the square root of 9 is 3 outside of the square root. So if you have a square root, then it's really just one factor. But if I were to ask what is x plus 8 squared, you know that you're multiplying x plus 8 times x plus 8. That's where that square comes from. And this is not just squaring this and squaring this, but actually foiling, doing the first, the outside, the inside, and the lasts.